Hello and welcome to this webinar. Firstly, I'd like to thank you for joining us here today for this very special reInvent recap on the latest advancements in AWS networking. We are lucky enough to have a great panel of speakers with us today who have a wealth of experience and knowledge of both AWS and network infrastructure. I'd like to point out that this webinar is being recorded and will be made available within the next couple of days. Joining us here today, we have Nick Matthews, an AWS Principal Solutions Architect, and Sherry Way, the CTO and founder of Aviatrix. So thank you both for being on the call with us here today. Just a quick question, have either of you managed to recover from reInvent as yet? Because it was a pretty manic week.
Barely. I've taken 7 showers.
And finally, myself, I'm Stuart Scott, the lead AWS trainer from Cloud Academy. Nick will kick things off for us today, where he'll provide a quick recap of some of the announcements made last week at reInvent before leading into a deeper look at the AWS Transit Gateway service. Following Nick, Sherry will then discuss how Aviatrix can help with the orchestration and integration with the AWS Transit Gateway across your VPCs and hybrid connectivity. Finally, at the end of the webinar, we should hopefully have some time to take some questions from you guys. So please do submit any questions you have into the question window, and our panel will happily take the time to answer some of them, time permitting. So that's enough for me. I'd like to get started straight away. So let me now hand over to you, Nick. Thank you.
Cool. Hey, everybody. Yeah. So as mentioned, I'm a solutions architect with AWS. My sort of day job is helping customers and partners architect networking things on AWS. So as you might imagine, at reInvent, we had an awesome conference. It was a ton of fun, did a ton of presenting and meeting with customers. We released a bunch of new services. So if you weren't out there, I don't blame you, but it was a ton of fun. So some of the sort of notable call outs, I think we launched, I don't even know how many things we launched. I think maybe like 70 different services. The ones, if you're sort of networking oriented, the ones that you would want to care about are the ones that we've got up here. So AWS Global Accelerator, which allows you to basically put a single IP address or pair of IP addresses in front of a service globally. So it's like a global load balancer of sorts. That's very helpful for anyone doing global connectivity. So if you want to do multi-region failover, or if some of your clients don't really respect DNS time to live, and DNS doesn't get refreshed for your clients very well, having a single IP address is helpful for both multi-region and within region sort of things. Shared VPC is one of my favorites. This gives the ability for sort of an infrastructure team or infrastructure VPC to create the scaffolding of a VPC, all the networking components, routing and subnet space and all those types of things, and create all that, and then share portions of that VPC out to lots of different accounts in the same AWS organization. And so if your developers don't want to care about networking, but you want a team that does want to control that sort of strictly, it's a really great concept. As well as Route 50 Resolver. So if you have troubles resolving DNS between on-premises as well as AWS, a lot of people were running like third-party DNS things in AWS, like Unbound or DNS Mask and those kinds of things. So Route 50 Resolver allows you to basically offload some of the DNS requests back to on-premises based on domains, or it also gives you a DNS entry that you can hit from on-premises. So you can directly hit our DNS servers for private resolution. And the sort of show of today is AWS Transit Gateway. And so we'll get into what that is as well here. So what is AWS Transit Gateway? This is my favorite animation, by the way. So Transit Gateway is essentially what happens when you glue routing and networking to cloud. So many of you may have been using other virtual routing solutions on AWS, where you typically, put a virtual routing software in an EC2 instance, and you try to make that do routing. We've made that work, and it works. But we had requests from customers that said, like, can you make this more cloudy? Can you make it sort of an AWS native service of some sort? And so we listened to that feedback, and this is sort of what we built. And some of the core components that people wanted here was around scalability. So, when I talk to customers, one of the first customer conversations I get into is usually, how many VPCs do you have? Like, and I don't need to know if it's like 11 or 15. I want to care if it's like 10, 100, 1,000. Because we've got customers with thousands of VPCs, and the bandwidths between those manage anywhere between, a couple hundred kilobits per second to hundreds of gigabits per second. So one of the interesting things about cloud is like that just diversity of the types of use cases and scale that we see, and we really make sure that our routing functionality can handle that. As well as whenever you have lots of VPCs, and there's lots of reasons for that, whether it's accounting or separation or billing or accidental, you don't want to have to create multiple VPN connections. Like you usually want like sort of a well-defined, either like one or two or some X number of connections on premises into the AWS cloud, so you don't have to keep adding connectivity to the cloud as you add things in the cloud. You just want that demarcation point. Because sometimes the networking groups on premises take like weeks or months to change things. They're not particularly, historically not known for being agile. As well as, people, when they come to AWS, they want to be secure. That's always one of the biggest concerns. And so, and even then, people want to be more secure in AWS than they can on premises. And we've proven we can do that. And I think with Transit Gateway, we show how we can make that actually easier. So, if we dig into some of the details a little bit, this is what it looked like before. You have one customer or one VPC, and that gets you, we've got a lot of customers that have been very, very successful with one VPC. So you don't need multiple VPCs, but sometimes you go, well, maybe someone else spun one up. Maybe we don't know them, or maybe there's an acquisition, or maybe we want a separate VPC for development as opposed to production. There's lots of good reasons. Someone wants a different bill. And then that sort of probably, if you want to connect those two together, you can go with VPC pairing. Although you might have some other people come in with VPCs, like I said, either more acquisitions, different groups, different billing, or whatever it might be. But now you need these VPCs to talk to each other as well. And so, they would pair these together. But we don't support peering, or, we can't just go in a circle here. All these VPCs have to peer directly with each other. So you actually have to peer everything. And so in this example, we've got 4 VPCs, and we've already started creating a lot of peering connections. And so maybe at this scale of 4 VPCs, this works. And then you want to connect on premises. So you create a customer gateway, some VPN, and you just want to connect it into maybe your shared services VPC or your sort of main VPC. But that VPN can't connect to the rest of the VPC, so you create more VPN connections everywhere else. And then maybe you scale up, you add direct connect. And again, you'd like to bring direct connect into your single main VPC again, but again, we don't route that across all the other VPCs, so you have to create direct VPN or direct connect connections into all of your other VPCs. And so this is, a less than awesome user experience. And so that's what sort of led to what Aviatrix is doing with their solution, as well as Transit Gateway. So now you have a VPC, you have 2 VPCs, you want to peer them. You can use Transit Gateway to do that. You can use VPC peering too if you want to. You don't have to. But the difference here is if you add more VPCs, you just connect them once to the Transit Gateway. If you want to connect VPN, you connect it once to the Transit Gateway. You want to add direct connect, you add it once. And so this is sort of your connectivity hub to a certain extent. If we get a little bit deeper here, this is what a Transit Gateway starts to look like, right? So it's regional. It exists in one region. So you can bring in your direct connect to VPN. Direct connect is a Q1 roadmap item for us, by the way. Scalability, like I mentioned, is one of the big things. So we can do up to 5,000 VPCs across different accounts. We also added the ability to add multiple VPN connections in. And so we support what's called ECMP, or equal cost multipath. So as long as you're advertising the same BGP prefix over those VPN links, then we will spread traffic across all of those. So we still have the existing 1.25 gig limit, but now you can add up to, something like 50 tunnels to get up to 50 gigabits per second of VPN bandwidth. And like I said, from the routing perspective, as opposed to using VPN to get into all your VPCs and the traditional transit VPC method, we're now actually using native network interfaces. So those native network interfaces, one, get rid of a lot of the bandwidth and scalability issues we have with VPN, but it also allows us more flexible routing. So those network interfaces will use the local VPC routing table to make decisions, and they're associated to a route domain or a route table. Those are interchangeable. So those route tables or route domains allow us to create more differentiated segmentation between our VPCs. One of the questions I always get when I start talking about this is they go, okay, well, Nick, you just told me that you put a router in the cloud. Is it going to break? Like when it crashes, do I hurt? Does this, like, what does this actually look like? How much bandwidth do I get? How does that work? How does it fail over? All those kinds of things. Because connecting 5,000 VPCs to a single router might sound scary to some people. So let's talk about the details so we can get comfortable with it. So Hyperplane is a feature that we launched, well, not launched, but started talking about at reInvent last year. So Hyperplane, it's a horizontally scalable state management service. So we deploy a whole fleet of these things, and it actually runs on EC2. But that whole fleet across the region has terabits of capacity. It's already in production. We've been using this for a while. It's not new. It's what's underneath Network Load Balancer, NAC Gateway, EFS mounts, and now Transit Gateway. And the way it works is as you add attachments, so you get one attachment per availability zone. So if you deploy your applications in 3 availability zones, you want 3 subnets for your attachment. Inside attachment, you'll get a network interface. We will basically give you bandwidth shards in that fleet as part of that. So we can go up to 50 gigabits per second on these. And as you add more network interfaces, we give you more bandwidth and more shards across our fleet. And so if any given single instance has a problem, it's a very small percentage of your available bandwidth capacity. As you add more network interfaces or more VPCs, those get sort of distributed across the fleet. And so we have this availability zone sort of data plane, but to you, it looks like one transit gateway that operates inside the region. And doing this across region is a roadmap item for us to use basically VPC peering. So we'll talk more about that probably next year. But let's make this a little bit more real. So let's just say that every VPC should talk to every VPC, or I don't want anything to talk to each other. I just want to send everything back on premises. How would that look? So the way you do this is we start off, and this is the default behavior of the transit gateway. So we have a VPC, we have a default route domain, and we would attach the VPC. So we would define those 2 subnets there, and then that would show up as a route. So it automatically will propagate that route into that route domain. And so we know that 10.1 goes to attachment 1. We can add more VPCs here. The first thing we do here is we add the route table. So in the route table of the VPC, we create a static route to the transit gateway. And that's because the route table here inside the transit gateway supports up to 10,000 routes. The route table in the VPC supports up to 100 routes. So there's no easy way to just propagate everything from the transit gateway into the transit VPC, into the VPC for the VPC here. So in this case, what we're going to do is we know that all of our VPCs, we're going to put in AWS or 10/8. So we're going to create a 10/8 route to the transit gateway. Now we can add the other VPCs. We'll add that same 10/ route to the TGW and all of those. And we'll start to see more routes show up here. 10.2, 10.3, 10.4. And each of those has an attachment associated with it. So this means that when a packet comes into the transit gateway, we take a look at that route table, see where it's allowed to go. In this scenario, we've got full connectivity between all of our VPCs. This is also good if you need to go over the 100 peering limit that we have. If you want to peer 1,000 VPCs with each other, this is probably the model you'd want to use. If you're more of the security conscious type and you say, hey, I have these VPCs, but they're not really friendly with each other, I don't want them to talk to each other. So you would create 2 different route tables or different route domains here. One for VPCs and one for VPN. So in this model, we would add a 0/0 route in each one of these VPCs that goes to the transit gateway. It says, I want this to make all routing decisions for me. In the route table for the VPCs, we would add that 0/0 route that headed towards VPN. In the route table for the VPN, essentially we say if it comes from VPN, it's allowed to go into my VPC. So you'd add the 10.1, 10.2, 10.3, whatever. All your VPC routes would get propagated into the VPN route table. And so what this really means is that there's essentially 3 steps here. The first step is you attach a VPC. When you attach the VPC, you associate that attachment to a route table. So that means basically when you associate it, it says, hey, where's this thing allowed to go? So in this scenario, we've got a 0/0 to VPN. These VPCs, even though they're attached to the same route table, don't have routes for each other. So that means they can't actually go in between each other. And then you say, okay, well, I want things to be able to get to my VPCs. How does that work? So when you propagate the routes, So I want to propagate the 10.1, 10.2, 10.3, and 10.4 VPCs to the VPN route table. That means if it comes in over VPN, it can reach my VPCs. And so you propagate routes to where you want to be reached from, and you associate the route table to an attachment for things that should be able to go. So it may take a little bit of time to understand that, but that's part of the reason why we're talking here with Aviatrix, so that you don't necessarily need to understand all of these concepts as part of our console, right? So in this model, we've got connectivity to on-premises, but not between each other. So maybe a little more security cautious. And you can sort of mix and slice and dice this and get very creative around how you want to do that. I think we'll talk about that here a little bit later with Sherry. So, just a quick comparison between Transit Gateway. The Transit VPC, I've presented on this and I've talked about this for years. It works. We've got customers doing it in production. We've proven this thing. It's not entirely perfect, but hey, that's life for you. So you have to manage some instances. I know Aviatrix does a really good job of doing that with their controllers. So that's a lot less painful than it is with some other solutions. It is using VPN as opposed to using network interfaces. The scalability can be a bit tough because some of the limits actually on the AWS side are a little bit more brittle in terms of packets per second and VPN and those kinds of things. And segmentation, unless you're sort of an expert or pro at that, it's actually fairly difficult to segment that. And so with Transit Gateway, we've made a native service. We do that management for you. We've converted that VPN into Elastic Network Interfaces. It's horizontally scalable, so you can do up to 50 gigs of bandwidth, 10,000 routes, 5,000 accounts or VPCs. And we're also given that ability to add additional segmentation on top of what you can do today with security groups and network ACLs. So I think it's hopefully a pretty good introduction for you all. So I'd like to hand it off to Sherry to sort of get into the details of, what this looks like and maybe what they can do with it.
Thank you, Nick, for the fantastic explanation. And as Nick mentioned, when your network gets bigger and more number of VPCs, it could be a lot of clicks or APIs to make a VPC to VPC connectivity work. So this is kind of an illustration. Say you have 4 VPC. This is to illustrate what Nick was talking about. See, you have 4 VPCs. You have a TGW, and so you have a TGW route table for 2 of the VPCs. They form a route domain, and then the other VPC 3 and 4, they form a separate route domain. And in the route domain, if 2 VPCs need to talk to each other, you attach the VPC to the TGW route table, and that will allow VPC 1 to talk to VPC 2. Now, by default, these 2 segments or 2 groups of VPCs, they have no connectivity. That's what the route table provides, a natural isolation. Now, if you want them to communicate with each other, what you need to do is you need to enable the route table propagation property in each TGW route table. And then what you need to do is for every VPC, the attachment ID, you need to program it into the respective or the other side of the route table entry. And you need to do that for the both pairs so that you have two-way communication. As you can see, when you have more number of VPCs, this gets fairly complex and very quickly. And it would do the job, but you can see this build out every time you add new one. So that is in the VPCs. And if you wanted to build connectivity, build a little bit segmentation, it's basically an illustration of how Nick went through about the number of API calls or clicks that you need to go through. Now let's talk about the hybrid edge part between on-prem and the VPC. You know how the TGW Transit Gateway run a BGP session with your on-prem, therefore your on-prem routes are all propagated to the AWS Transit Gateway, or we call TGW. But the VPCs, the spoke VPCs, they do not have the propagation to the spoke VPCs. So what Aviatrix, so by itself, the TGW, the routes are not in the spoke VPC. So what Aviatrix provides is software-defined solution with our Aviatrix controller to propagate the routes that showed up in the VPC TGW route table and to program to the spoke VPCs. Because on-prem routes are dynamic, they change. Unless you have a BGP-like function, you will not be able to keep them in sync and updated and function correctly. So another recap of how Aviatrix works, we leverage all AWS native services. We are cloud native plus, meaning that we build value. You let our customers use native service as much as possible and then build value on top of that. And to further abstract the concept of segmentation, we define a concept. It's built on top of a AWS route table and route domain propagation. We create this abstraction that contains what we call security domains. And security domain, in the security domains, all the VPCs that are attached to or the member of the security domains will have full connectivity. And Aviatrix controller takes care of programming the TGW route table entries as well as all the VPC route table entries. So you can stay at the policy or specify the domain level instead of going to VPC level to the VPC route table level. Now, on top of that, we also introduced these connection policies. This is a abstraction built on the propagation property or attribute of Transit Gateway. And this allows you to say, I have multiple security domains, and whether or not I should allow different security domains have connectivity to each other. And Aviatrix Orchestrator, what it will do is it will not only program, again, the VPC route table and TGW route table entries, but it also will build the full connectivity to all VPCs in between these two domains. And of course, if you have the two domains have no connection policies, they will not have connectivities. So that is an abstraction layer simplifies the operations that you have to do with building a secure segmented network. And next, let's talk about what are the use cases for the Transit Gateway. Obviously, it's a significant step forward in creating a network architecture for enterprise and for all in the cloud. Obviously, in this case, Aviatrix orchestration handles isolation for let's say if you have all in cloud, we provide ability to let you specify, design policies and build and view and test troubleshooting abilities so that it abstract out all the details of the clicks or the number of APIs and to keep the connectivity correct and monitor and make sure there's no policy violation. And building on top of that, we at the edge we provide we call Edge VPC. Transit Gateway as it is being released does not offer Direct Connect yet. But Direct Connect customers can immediately leverage the Aviatrix solution and start to use TGW. The Aviatrix Transit Gateway that deploys at the Edge VPC will exchange routes with the on-prem, and then the Aviatrix Transit Gateway will communicate the routes to the controller, which will program all the spoke VPC. Remember earlier I talked about how the routes are not propagated to the spoke. So functionally, it's not complete unless there is either a BGP or there is a controller orchestrator that finishes the spoke VPC to ensure you have full two-way communications between spoke and on-prem. And whenever there's an on-prem change, network seeder block changes, it automatically reflects. And our Aviatrix architecture handles multi-cloud. You can hook up a spoke. Let's say your main deployment is in AWS, and you have Azure, some workloads, you have some Google workloads, and you can hook up. And in case if you need encryption, you can use Aviatrix Gateway that provides encryption. So that is what Aviatrix provides in terms of end-to-end solution to support your cloud deployment. And adding more to the edge, we have put a lot of development to that. Is today transit solution is capped at 1.25 gig performance, as Nick mentioned, and we have developed a technology called insane mode. Its use case is really three. One is high performance transit. Second is encryption over direct connect with high performance. The third is bypass VGW 100 route limit. If you have large deployment, you may have come across these challenges where your on-prem routes, it's very difficult to summarize, and both between on-prem and the spoke VPCs as your deployment gets bigger. So this insane mode allows you to have single instance with the Aviatrix hardware appliance to achieve 10 gig and 20 gig performance. And encryption is really ice on the cake because the technology is really about utilizing multi-cores to the modern CPU technology to achieve high performance. So that is, and more on the edge, you can deploy transit DMZ. This is similar to a lot of enterprise architecture deployment model where they want to have a DMZ VPC where they can put third-party firewall devices. And they don't really want to build IPsec to these connection devices. They want to decouple them so that they can scale independent into each other. So we have a DMZ where you can drop in your firewall devices, and we control the traffic spraying and we control the HA. We take care of the HA of these firewalls. And this is an architecture a lot of enterprises are familiar with, and they wanted to use this to control traffic north and south and ingress and egress as a single control point. Again, all the in-cloud interface through TGW, so you can use all native services. And there's another pattern that we see very often is customers, the cloud workloads are different, and oftentimes the VPCs need to access internet directly, but needs policy enforcement with the domain names. So we offer Aviatrix egress filter is centrally managed by the controller, but distributed, executed by these gateways you deploy, and it's completely inline and transparent, and allow you to do wildcard filtering, host name filtering, and it works for all port 80, 443, all TCP and UDP ports. So let's take a look at how Aviatrix Orchestrator works in action. Aviatrix Orchestrator is a function of our controller, which itself is an AMI in AWS Marketplace. I recommend you to run metered AMI, so you pay as you go. It's the agile model of cloud consumption. And you use this controller. In this case, your security team can define policies. In this example, let's say we want to simply, of course, you can have as many domains as you like to divide, but in this simple example, let's say we have a prod domain and dev domain, and our policy says they cannot communicate, but they both need to talk to share service. So once you define the policies and the security domains and connection policies, all you need to do is build. You just drop the VPC, attach them to the security domain, and based on the security domains policies that was defined in the plan stage, all the connectivity will be built. The routes are updated, and things will start working. And again, I talked about the edge for a few slides, and obviously you can deploy edge by the controller, deploy our gateway, and you can reuse what you have built for your direct connect, all the VGW, you can reuse all the cedar blocks, you can reuse. and it hooks up. Our edge VPC behaves to the transit gateway as another spoke, and it has the, Aviatrix does the magic to make all of this work. And obviously, you can keep attaching more VPCs and keep building out. The controller is really doing the BGP function in the cloud of propagating routes properly and make sure it's functionally complete and it's accurate. It doesn't matter what your on-prem CIDR blocks are. So that concludes my part of presentation. Thank you.
Thank you very much for that, Sherry. Really appreciate that. It's interesting to see the integration that Aviatrix has with the new Transit Gateway and the simplification that it offers as well, along with a whole host of those use cases that you went through. So thank you very much. So what are the next steps from here? Well, shortly you'll receive an email with a link to this webinar, the recording of the webinar, and also the slides as well. And there was a lot of information that Sherry went through there. So if you have any requests for additional demos, or if you have any questions about migrating from your existing Transit VPC to the new AWS Transit Gateway, then please do send an email to Aviatrix to info@aviatrix.com. There's also a free trial on the AWS Marketplace as well that you might want to take a look at. And for any enterprise training on AWS and the cloud ecosystem as a whole, then also please do visit us at cloudacademy.com. So now it'd just be good to run through a few questions, and we've had a few questions come in during this webinar. So I'll start from the top and see how we do for time. So the first question that's come in is, can you help me understand with AWS Transit Gateway and Aviatrix, does it use BGP?
Okay, I'll take the answer. So there is big echo here.
Go ahead.
Yes, I'll take the answer. So the Transit Gateway is a software defined. Transit Gateway could run BGP to on-prem, but between Transit Gateway, so to on-prem, today Transit Gateway supports VPN, which runs BGP, so that's how you collect your routes. But between Transit Gateway to the spoke is not, there is no BGP routing, and it is our job, our responsibility to make sure the routes are consistent and they functionally complete. Yeah. Does that answer your question? Okay.
Great, thank you. Next question. How do the spoke VPCs learn about and get the on-prem routes?
Okay, I think this is for Aviatrix. I'll take that. Again, the controller is the one really does the BGP function. It's the magic that picks up the gateway, transit gateway from the on-prem with the BGW and then program the spoke VPC. So either you do a BGP function propagation or you do a software design. And in our case, it's a software design.
Excellent, thank you. We now have a question about pricing. How does pricing work for AWS Transit Gateway?
Sure. So, because I explained some of the hyperplane stuff, it might make a little more sense. But when you create attachments in your VPCs, those will have an hourly charge, similar to like private link or almost network load balancer like pricing. And then there's a data transfer charge through the Transit Gateway. It's like in Virginia, for example, it's 2 cents out of the sending VPC. So the person that owns the Transit Gateway doesn't own that charge, it's the account owner. And so, for example, like VPC peering between two VPCs is 1 cent in, 1 cent out. So if those two VPCs are sending traffic to each other through the Transit Gateway or owned by the same account, it's price neutral to VPC peering, basically.
Great, thank you. We have a couple more questions. How would you route all traffic from the VPCs to a next-gen firewall before it goes to either Direct Connect or VPN? And again, in the opposite direction as well.
I think this question is for me, yeah. So I think you're referring to the Transit DMZ. In this case, the Aviatrix use actually AWS routing infrastructure. We really rely on all the AWS infrastructures for the magic. I mean, the Aviatrix gateway will send the traffic to the firewall device, and firewall device on the other end sent to the next Aviatrix gateway, what we call a sandwich mode in the middle. That's how it works. Rather than which will limited performance firewall.
Okay, thank you. I think this one's for yourself, Nick. Can you confirm that AWS Transit Gateway cannot, at the moment, connect to another transit gateway in another region?
Yeah. So today, the transit gateway is regional, and so you can use it within the region. So for the most part, within one region, I would probably recommend using one transit gateway as opposed to multiple in the same region. And across regions, you could do something like basically sort of use a transit VPC with the Aviatrix solution to peer those together, but there's no native peering between transit gateways in different regions today. That's something that's coming soon for us. And I think, Stuart, when Sherry's talking, you may want to mute because I think there's a little bit of echo on that last one.
Okay, thank you. Sorry about that. I have a question for you, Sherry. In the Aviatrix Transit Gateway model, is it necessary to deploy Aviatrix gateways in the spokes if you want egress filtering? Or can we not just use the main Aviatrix gateways in the transit VPC instead?
Yes. So if you want to have a centralized firewall, then no, you do not need egress. You do not need to deploy in the egress VPCs. But if so, you just use native transit gateway service to the spoke. But if you like distributed, because each VPC may have different policies and different URL destination they need to go to, and a variety of reasons you want to have no performance bottleneck and things like that, then you do need to launch a Aviatrix gateway in the spoke for the egress.
Great, thank you. Another one here for yourself, Nick, regards to shared VPCs. They say that they currently run OpenStack internally and rely exclusively on Neutron provider networks. They view shared VPCs as provider networks for AWS. Has there been any discussions about raising some of the per VPC limits, which will become extremely constraining when leveraging shared VPCs?
Yeah, so I mean, we get a lot of customers asking us for different sorts of limit increases. So one of the components of shared VPCs is that, like, while you can send different accounts, different parts of your network, the owner of that VPC that you're sharing those parts out with, the subnets out with, we haven't increased the limits for that. And so, for example, there's a limit of there's a soft limit of 20 network load balancers and interface endpoint combinations. And so you want to think about when you're doing VPC sharing. So we don't really talk about roadmap on these types of things publicly. But if you want to send me an email, my email is nickmatt, N-I-C-K-M-A-T-T, or anyone else that has questions. I'm happy to take some of the roadmap sort of stuff, private over email.
Great, thank you. Just got a couple more questions coming in. If you guys are okay to continue to answer.
Sure.
Since Transit Gateway is a regional resource, how do you scale the security domain construct across the region? And can Aviatrix do that as well?
Yeah, this is a great question. In fact, what's going to happen next in our roadmap, customer have asked is, this security domain construct, can you extend to on-prem? Because on-prem I have dev, I have, segmentation is always the best practice for reducing blast radius, both for reducing blast radius and attack surface. I have many stories to tell because we work with hundreds of customers. That's why this is a high priority. Even cross regions, this would be a great concept that you can say, I have a dev, I cross different regions. I want this domain to extend beyond. So this is definitely something that we are working on to build.
Okay, great, thank you. Sherry, I just want to go over a previous question because there was a bit of an echo during the answer. It was the question relating to how would you route all traffic from the VPCs to a next-gen firewall before it goes to direct connect or VPN, and the opposite direction as well. There's a bit of an echo on the answer last time, so if you could just answer that one again, that'd be great.
Okay, sure. That was my transit DMZ slide. Traditionally the firewall and the networking device currently needs an IPsec tunnel, and that significantly reduces the firewall performance. Firewall should be doing firewall functions. So what we are releasing is really using AWS infrastructure, using AWS VPC routing infrastructure, and passing packets between the Aviatrix gateway and the firewall. And we're the one that making the control points. We're the ones directing the spraying the traffic and making sure the session that going into one firewall coming back to the same firewall. Yeah.
Great, thank you. Appreciate you going over that again. One for you, Nick, here. How will transit gateways be used in conjunction with direct connect connections, and is that currently available, and if not, when will it be available?
Sure. So that's a roadmap feature for us for Q1. Since it's still sort of in development on our side, the implementation details are still being worked out. It will likely include Direct Connect Gateway, since that's the preferred direction for Direct Connect going forward. So Direct Connect Gateway allows you to connect multiple VGWs to one interface on your Direct Connect. It also allows you to go across our backbone and across the world to different areas. So it's a better model than the direct virtual interface method. But that said, it's still roadmap, so it's still subject to change. So we'll just have to sort of stay in touch. If you have contacts with your account team or TAM or those kinds of things with AWS, we can help you stay up to date with those kinds of things as well.
Right, thank you. Sorry.
If I can add to that, part of the value add of Aviatrix is we support Direct Connect right now through our Transit Gateway at the edge VPC. So like I mentioned earlier, the Direct Connect customers can immediately migrate. And obviously when AWS Direct Connect comes, you can migrate your bottom half. So that you can leverage the native Transit Gateway service now.
Thank you, Sherry. We have a question about VPN connection this time rather than direct connect. To connect the Transit Gateway to your on-prem data center, what will the Transit Gateway broadcast in order to configure the VPN connection?
Yeah, so in that model, the routes that are in the route table for the VPN will be re-advertised back to on-premises. And so if you're propagating routes from your VPCs or even other VPNs, that's what would get propagated back to on-premises.
Great, thank you. We'll just do two more questions and then we'll kind of wrap it up there. A question here regarding security. For security purposes, is deep packet inspection available in Transit Gateway, Aviatrix Edge VPC, or Aviatrix DMZ?
Nick, do you want to go first?
Sure, I'll start with that one. Yeah, so I mean, I did a presentation at reInvent Net 402 for those that are interested about some of the architectures of how you would put like next-gen firewalls and some of those inspection devices in the Transit Gateway routing flow. So it's possible. We've worked with some of the folks like Checkpoint and Palo Alto to validate those architectures at launch. So those folks are generally pretty ready to be put in that environment. There's no native deep packet inspection as part of Transit Gateway. And Aviatrix has some ways to work with those types of people too. So Sherry, maybe you can sort of take it from there.
Right. So in the Transit DMZ, when I say third-party firewall appliances, that's exactly what I have in mind. I didn't mention these vendors' names, but you can think about all the ones who can do deep packet inspection, IDS, IPS. They can be put it in the sandwich between the Aviatrix gateways and through AWS routing, and will work seamlessly together.
Okay, we'll have time for one final question. I think it's going to be for yourself, Nick. Can you advise on cutover planning for customers that already have transit VPCs in place and want to replace them with Transit Gateway? Actually, it could be one for you as well, Sherry.
Sure. Yeah, so that's something that we're getting demand for as customers get more comfortable with Transit Gateway. The way I see this is you go into you create a Transit Gateway, you create attachments to all your VPCs, and then you would basically your transit VPC that you have today, instead of having VPN out to all your spokes, you then create the Transit Gateway as sort of a spoke to that same VPN model. And so now you've got all your spoke attachments through the network interfaces of the Transit Gateway. You create VPN between your Transit VPC and the Transit Gateway. And you can keep that if you want, because it gives you sort of a nice edge in front of your Transit Gateway to like on premises. So if you don't mess with those tunnels, or if you want to go log into a device and get more detail than what we provide natively, or that could be a firewall, or it could be an SD-WAN thing, or a number of other things. But if you do want to get rid of the VPNs to that device, you can do the VPNs, then switch to your on-premises VPNs directly into the Transit Gateway. And so that's how you could do one of the migration models there. And I think, Sherry, you guys can do some stuff too, right?
Yes, we have, if you go to docs.aviatrix.com and you click on TGW Orchestrator, we have an entry about how to migrate transit CSR to the Aviatrix plus TGW based procedures or processes.
Excellent. Well, thank you very much for taking all those questions. There's quite a lot coming in. Sounds like an interesting topic that a lot of people are keen to learn and use about. So thank you both very much, Nick and Shay, for your time today and presenting and taking all those questions. And thank you everyone who joined the webinar as well. That's the end of the webinar, and like I say, it has been recorded, and you will receive an email notification shortly with a copy of the recording and the slides. So thank you both again, and speak to you soon.
Thank you so much. Thank you.
Thank you.
Thank you.
Bye-bye.